And I just like happening and like innovation, whatever. Like yeah, like Thursday and Friday.
They also take a minute to make sure they understand how to do the date. So fast.
Yeah.
No, I'm not like fake orange,
So.
I know, like, just try to out loud. That's one of these.
You learned that last week.
One.
Oh, yeah, it's not.
Yes.
They said that's something stuff. Oh, wait.
Yeah, so this warm up, not warm up, but the okay, folks. So about how long should this problem take you?
2 seconds.
2 seconds, that quickly, is that right? Do we agree? How would you do that fast, Holden?
Have the 2 angles and that's the exterior.
Are we good with that? Brings back good memories from geometry? Why is that true, that some of those 2 angles is equal to the exterior angle? Yes, Amir?
So like the angle opposite to X, or like the X is like we should call it like Y or something, that angle. It's equal to 180 23.
Okay,
So it's
X plus Y should equal
yeah,
180.
X plus Y with 20.
so these 2 angles add up to 180, and these angles plus this one at 180, so it makes sense that they should be equivalent to X is 23. Okay, just a throwback for you. We'll do the warm up after this. That was the unofficial warm up. But let's talk about what we're getting into. And I haven't looked at your test yet. I'll be starting today, and you'll at least know how you did on them next time. I'll try to give them back to you, but until everyone's taken it, I can't return them. So be patient, please. So we have our next unit is on the unit circle and graphing trig functions. How many of you have seen the unit circle, just out of curiosity? Okay, so almost everybody. So we're going to review it quickly. And then get deeper and deeper. You can see there's a little bit more information on here. But we do have a quiz coming up Tuesday, October 1st on days 1, 2, and 3. And when I say days 1, 2, 3, that refers to the days of the unit, not of the cycle. So although they might coincide, it's these 3 things that we're going to have that quiz on. So the same day we're graphing tangent and cotangent. Have you graphed tangent? Done this? I know many of you have graphed sine, right? Sine, cosine.
It's like
Yeah, exactly. We'll be graphing all those things from the start. But yeah, we have a quiz and then we have a test. And after that next test, you're going to switch up. By the way, remember, if you're a lefty, no matter where you're seated with a partner, you're free to switch, so you're not bumping elbows throughout the unit.
okay.
And you can do that now or later or whenever. And that goes for the entire year.
So
You're lefty?
yeah.
Yeah. Okay, watch out. Watch out then.
Okay.
Okay, yeah, me too. Okay, warm up. Another throwback.
Fine. Oh, why? Oh, it's just like. Yeah, so
Let's see what you got.
over this.
See what you. Go ahead and work on it. Write it out. There should be a few blank sheets of paper at the end of the unit if you want to work there. I think I put in a few. Are there some there? Yeah.
What does that first thing say?
Measure.
Measure of arc AB. Sorry, that is an M. You're welcome to discuss it with the neighbor, of course. I know it's been a while for many of you. Or maybe where you did this didn't have the same locations.
It's on.
Yeah, sorry. It's just, PV area is just, fine. Circle. This is for space. Just. She's in. One is one. Here she. This is 9. All right, just relax. 9. 40 is 182. Oh, yeah.
No, I thought it's going to be numb.
I got. Wait, what was that?
Got C as in
Oh, C.
C, sorry. Wait, no, yeah, I'm just like,
Okay,
I'm
okay.
going in.
I was like, oh, I've got area of sector. EP. Oh, so sector I just did say. Area. You can check in with your neighbor when you are done or stuck. Make sure everything's going smoothly.
See what I'm saying? Oh, wait, no. Yeah, mine is.
It's a triangle.
What'd you get?
My trip's double tripping. 486. Yeah, 2.
Oh, no. Yeah, no, I think you're right. Is there enough information for these problems?
This?
Right.
Just go 40 over 360. 40 is 2 rows. Because you're finding, if it's the length of it, you find the diameter of the circle. It's 40% of the diameter. Oh, wait.
Are we about ready?
2, wait,
Yeah.
2 is 5.
15 seconds.
Oh, so this is times 192. So it's 2 pi.
Yeah, okay.
Okay.
Okay, that's what I thought. That's-
Time is up. Let's talk about it. On the count of 3, if you know the answer for part A, I'd like to hear it. 1, 2, 3. Yay. That's a hard one, I know. Measure of an arc is the same as the measure of its central
Central
angle.
A.
How do we know that P is even the center of this circle?
Because it's
Given, right? The circles are named by their centers. So we could rest assured that P is the center. Who could help me with the length of arc AB? How do we do that? Yes, Amir.
It's 2 pi, but it's just like basically 40 degrees.
The length is 2 pi? Okay, so how did you get there?
So 40 degrees over 360 degrees times which is just 18.
9. I'm gonna put here. What letter? Do you use the letter for this or just do the number?
Understood.
This is calculation. And when you did this, I guess you canceled this, make out a 1/9 here. Somehow you got that 2 pi. And of course, units are centimeters. Yeah? Any questions? Thank you, Amir, for C. Lydia?
It would just be the same 40 degrees over 360 degrees, times pi r squared, which in this case would be 8 pi.
Okay. Cool. And when you simplify that, you get 9 pi. 9 pi what?
Centimeters.
9 pi square centimeters. And of course, to cancel this, I may actually go back to the part B and just start with a 1/9. Would that make any sense to use what we've already done? And then maybe just cancel one of the 9s instead of, it's not difficult to see how many times 9 goes to 81, but yeah, ultimately we get 9 pi square centimeters. Yeah. Are you comfortable with this? Doing this kind of thing, the fraction of the circumference, fraction of the area? And that fraction is, of course, the degrees of the central angle or degree, the measure of the arc over the total number of degrees in a circle. Okay, let's get on with today's business. And you're about to talk with one another again. I was supposed to make popsicle sticks with names for today, but I didn't have a chance. So next time, I'll try to have those ready. So for today, it'll still be voluntary. Angles and measures. Would you please discuss with your neighbor what you remember about, like, what's an angle? How is it measured? What do you remember about this?
Just.
It's measured.
Oh, well.
You have to make a graph.
Not exactly sure.
Guys.
No, I was like, I don't think she out how they, and it's like,
What is it? That's so.
no, I've been.
Phase.
Yeah.
Okay, so the ingredients of any angle is to raise, exactly, with a common
Initial point.
initial point or common. I think raise all have an endpoint, so they have a common endpoint, which is kind of strange because it's where they begin. But so they have a common endpoint, and then that common endpoint becomes the vertex of the angle. And it's kind of difficult to word, but I hope it makes sense that an angle is just measuring the difference in direction of the two rays. Does that make sense? And that can be measured either in degrees or radians. Would you just take a moment? I don't know if you already talked about radians, just to make sure that the people around you know what radian is. We're gonna be talking about it. Just check in. Do you know?
Yeah, yeah, it's like, it's like. Unless I was.
I know.
It's pi. Better eight.
Yeah, it's like in measure.
Pi.
But the radians,
Yeah, it's like the big thing over.
it's like how to explain.
And or equal to the same.
So what are you pi?
Okay,
I will use any other.
we'll talk about radians in just a minute. Did anyone find themselves at a loss for, maybe you knew what a radian, like how to use radians, but you didn't know how to describe what it is? You find yourself at a loss for that? Yeah, I feel you. And I have a hard time describing it too. So let's start with degrees and then we'll go to radians. All of these are going to be in standard positions, which means every angle has two parts. One of the rays is called the initial side and the other side is called the terminal side. The initial side, when it's in standard, always is this direction, positive x-axis. So when we're talking about 90 degrees and in standard position, that means I want to see this. And then 90 degrees, I need my other ray to point. Are there two different places it could point?
Yeah.
Well, as I've oriented this, you can probably see I'm going to focus on only one of them. We count counterclockwise to get to the other one. So 90 degrees, and I'll indicate that with the little box thingy, I think is what that's called. So that's in standard position. So do you see what 310 degrees would look like? We always start with this. And of course, 310 means we're going here. Does that make sense? So it's unclear that I've drawn a 310 degree angle. In order to make this clear, what I'm going to do is, do you know? Yeah, I'm going to make that arc say we're going this way. I'll put my 310 degrees right there. I'll give you a moment to finish the next four. Check with your neighbor once you have finished.
Revolution show like on the Friday night.
Oh.
Like, you know, this is totally.
It's like, you subtract 360, you get to
Yeah.
I didn't show it to you. I don't know, it's a price person. No, it's fair. Okay, so where do all these begin? It's standard, so they all begin in the same place. I need you to have this ray. You have that on your paper? Can you show me where the other ray is? You can use your pencil or your arm. Where's the other ray? So, okay, so look around, make sure everyone's pointing in the same direction. Okay, so I'm saying something like this, is that right? Yeah. Okay, so maybe here. And how do we indicate that this is a 720-degree angle? You know, what are you thinking? Yeah, do some swirls, right? We start here and then blow past it. Right now we're at 360, so we continue, and then we're at 720. This is not good. Sometimes that's helpful. This is, you know what I mean. You know. Oh, wait,
Draw like concentric circles.
I just have to be quick. Okay, this way, 720 degrees. And of course, this 750 degrees. And this brings up a vocabulary word, angles that coincide with each other, or coterminal angles would just end up at the same place. In other words, 750 degrees would look exactly like an angle that is just 30 degrees. So that would be called coterminal. Does that make sense? Either 30 degrees or
390.
390 degrees. Those are all coterminal angles. 210, in this case, we start this way like we always do because this is standard position. Negative 210, will you please show me where we're going to go? Yeah, okay, so are you all pointing in the same direction? See, so negative, how are we going to do negative? Yeah, we go lock this now. So we start with that 0 degrees, 108, negative 180, and then negative 210. Did I do that right from your point of view? So this, like that. Then, of course, to make sure we're doing the directions, something like this. Which is coterminal, of course, with 150. I know you do that. Okay, -4 is 75. Please show me where the terminal side is. Everybody, show me where that terminal side. Are you still working on it? I know this take a really long time. Because I'm saying this way. Is that saying? I was saying this way. I was saying different things. Okay, who'd like to tell us how to get there? Yeah, no, help us out.
2 revolutions, so 720 degrees.
So how many revolutions? 2 revolutions?
It's not too.
Or why 2 revolutions? So we're trying to get to the negative 475, right? Okay, so I'm gonna go in a negative direction. First, I'm gonna go 360. Yeah, Eileen, you want to continue from here?
I usually subtract 360.75 to get 115.
Ah.
And the one's revolution and 130.
Did anyone else have this kind of calculations, maybe informally in your head? Okay, nice. And this, of course, tells us that I'm not done yet. I've gone 360, I still have to go 115 more, which is a little bit past 90, something like that. Does that seem about what you did? Now, how far past 90? 90 minus 125 degrees, so I think that seems about right. So negative 475 degrees. Yes, Ria?
Like, once you do like 475 minus 360, you get like 115.
Mm.
And then like from there, wouldn't you just do, well, I mean, it's like more calculation, so like, would it make sense to do like 360 minus 115 to get 245, and that's 245?
Oh, interesting. So after you, so you said 360 minus 115?
Mhm.
Yeah, this is fine. And I think, no, I think this is probably what you were saying. Oh,
Yeah, we're on the same.
okay, so you're going,
Well,
Like a no.
It's 720. So
Okay.
we get the same number as that.
so your milestone was like to go too fast and
Yeah,
find the difference.
yeah.
Something like that.
I didn't know about the swirl thing.
Okay.
Yeah, no, I'm just ignoring that just to know like on a regular unit circle, like where you like this, you know, where the arrow's going.
Oh, that's coterminal, but
Yeah.
like the basic coterminal.
Or,
Yeah, they're different.
360 and then 115, so like.
Okay, so we have this, a 360 and then another 360, but
Or actually, the calculation makes sense, but like actually thinking about it, it's like the angle goes like clockwise, so it goes like 360, which is one revolution. And then you still have 115. Oh, wait, that makes sense. You don't go one. Never mind. Okay.
and there are different ways to think about this. As long as your logic is consistent with what we're doing in class, it's up to you. Just make sure that it's eventually efficient. Yeah, I like the idea of subtracting the 360 out of it. Like, why go the extra revolutions? Yes.
on a test, would you want us to draw the swirls?
Yes. Yeah, if it's saying to draw this angle, I want to see that indicated. The swirls, yes.
Draw a 5,460 degree.
There's one problem on that test. Let's
Let's
see if he has as many reasons that I need. 22.5 is not so difficult. 22.5 is special because it is
A decimal.
half of 45. Did anyone reference a 45-degree angle when you were doing that?
Yeah.
Because 90 degrees is pretty easy to graph. 45 from that, half of that, so 22 and a half. If you want to get some accuracy, you can kind of think about that. But really all you need to do is say, okay, I have starting, and then this, and then it's perfectly fine if you just label it like that. I'm not going to be getting a protractor for accuracy.
It has to be like the same quadrant.
It has to be the same quadrant. Yeah, if you do this, 22.5, I don't know what to say. I can't mark it wrong, but I'd have to take off a little bit, or at least a comment. I definitely have to shake my head for at least that. So 2.5. I do want a little bit of accuracy, so do the best you can, please. Again, you never need a protractor in this class, and I don't care if it's 10 degrees off. But it should be in the same quadrant. Okay, we got radians. The main thing you need to know about radians, for those of you who haven't studied it, is that 1 radian is equal to how many degrees? 180 degrees. Right, that's the main thing. Does that make sense for those of you who study radians? That's pretty big. That 180 degrees is pi radians. And from that, of course, 2 radians would be equal to 360 degrees. Yeah.
2 pi radians. Just 2 pi. And 1.
I'm sorry. I'm sorry. You're correct. It's pi radians and 2 pi radians. So sorry. That's a terrible mission there. Pi radians is equal to 180. Thank you for knowing what I meant. So, and how do you know if something is given in degrees or radians?
Radians is radians.
How do we know this is radians?
Because there's no
degree.
units.
Yeah, there's no degree symbol. If I had a 60 here without degrees, that means 60 radians. So don't assume that because there's a pi, it means that it's radians, but usually if we see pi, then it is in radians. So if you want to convert to degrees, we're going to talk about unit circles specifically tomorrow. But we could think, okay, this is radians. And I'm just going to go to science and use some unit analysis. Does that sound like something you've done in science?
Yes.
We're getting conversion. And I have radians on the top. I want to cancel radians. So I'm going to have the fact that pi radians is equal to 180 degrees. And I could just do some work from there. How many times does 12 go into 180? 15 times. 15 times, oh, that's 50. 15, 5 times 15 is something like 75 degrees. We're still left that degrees mark. So 72 degrees, you see how to convert that one? And we have degrees on the top. Check in with your neighbor. Once you're done or it's done. Okay, so on the bottom you put
Yes.
180 degrees, top you put pi radians. And since remember radians is, if there's no symbol, we know it's radians. So I'm gonna stop writing for radians or red. And does anything cancel?
Yeah, 72, yeah.
Yeah. What does it simplify to?
2 pi, 2 pi over 5.
2 pi fifths? Or 2/5 pi? Right radians? You may, but it's a little redundant because without it, it already means radians. Not redundant, it's superfluous, it's unnecessary. This one, I changed this one to 67 degrees. Have you seen this before? 67 degrees and 30 minutes. Yeah, so, and traditionally degrees have been broken up not to decimal, but to minutes. So how many minutes do you think are in 1 degree? How many minutes in 1 degree? 60 minutes, 1 degree. And then each minute can be broken up into parts. And normally they're broken up into, how many parts do you think? 60 parts. Each part is called a second. So if it's 67 degrees and 30 minutes, are we going to convert that to radians? I'll give you a minute to work.
Wait, is that the new one we're doing? Like, is that?
Yeah, you're gonna do this one instead of the 22. It's 30. Maybe convert it to decimal first.
Dang those Babylonians.
What's that? Yeah, the Babylonians.
I don't like this minute thing.
What's that?
It's like this minute thing.
Yeah,
Yeah.
the sexagesimal, is that what it's called?
Yeah, but like.
By
1 degree equals 60 minutes, right?
Yeah.
Why 60?
like go by.
Wait, sorry, wait.
How do you say 1 single degree, 60
Oh,
minutes?
60.
You get it 30.
30
It
minutes.
looks at it looks at their.
Oh, that's like.
There. Yes, I know how to measure this in 60s.
Top.
That's exactly how you.
I have friends,
Yeah.
their fingers up.
7.5.
Yeah, that's too little. You need, oh yeah, no.
Wait, so now from there, now we're just version. But this is
Is equal to.
Were you successful? Let's make a decimal first. 67 degrees and 30 minutes is the same as 67.5. Is that clear?
Yeah.
And of course, that 0.5 came from the fact that we have 30 out of 60. That's just our 1/2 there. So 67.5 degrees. And then that's what you're changing. Did it work out nicely? Degrees on top, so these degrees on bottom here.
How do we set?
Oh my gosh, how do we do this? I think that's equal to 67.5 pi over 180.
You don't need to simplify.
But we do need to simplify, of course.
Okay.
But at least we have this. We can at the very least get an answer. I do expect you to simplify, and if you have a decimal in a fraction, it's generally not considered simplifying. So there are a couple ways we can get out of this. No, do you have a suggestion?
Multiply by 2 on both sides.
What do you think? Multiply 2 top and bottom? Would that get rid of the decimal?
Yeah.
That's a really nice one. You could also multiply by 10, which is simple multiplication, but then you're way overdoing. it. So I like your idea of multiplying by 2. 67.5 times 2, 120, 135, is that right?
Yeah.
Over 360. And now, of course, we could divide a little bit easier by fives or maybe more than that. I don't know.
20.
I'm gonna multiply by
Let's just say 5 first.
27 over 72.
Oh, you divide by
45.
Look at-
Divide by 45.
You divide by 45.
You just divide by 45?
Yeah.
I would never. So I'm just gonna multiply by, I divide by 9.
Oh, okay, yeah.
Did I do that right?
Yeah.
If we would have divided by 45, we got the same thing. 3 pi over 8 what? What's the units? Radians. Do you have to say radians? You don't even have to say it. You have to know it. I'll give you a minute to finish these 4. Okay, let's go over this. That 5 pi over 2, how'd you do that?
Just convert to the degrees here.
Like that. So multiply by. It's radians, so pi has to be on the bottom. 189.
Yeah.
50 degrees.
180 times 3.
Yeah.
So 360. Is this it? By 360.
Well, it's fine, like we just said.
Was it 90?
Yeah, just.
But like, yeah, no, I know you.
Is that right? Is that?
And then you have.
Yeah,
one
it's like
revolution.
77.
Swirly. I need to put that box so we know how many degrees that is.
Yeah.
Because you're.
And I don't think we need to put a number there. If that little box is there, it just happens to be indicated. Any other input about how we do this? Yeah, okay. I'm gonna talk about the 3 pi over 7 because I think you'll agree with me that it's a pain to convert that to degrees. Let's just think about this as 3/7 of pi. And you know that pi is how many degrees? 180 degrees. So I'm just going to make an angle that's a little bit less than half of 180. Does that make sense? Just a little bit less than 1/2. Because 3/7 is less than 1/2. So I'm just gonna go ahead and. There we go. How do I know that's 3 pi over 7? I'll mark it. 3 pi over 7. Am I in the right quadrant? Yeah, I'm in the right quadrant for sure. That's it. I know all that work. None of it necessary. If you're just drawing, again, I'm not getting out a protractor. You should be able to get a accurate degree measure, but it just asks you to sketch it. If this would have been 4 pi/7, then it would have been
Or second.
the second part, like was symmetric about that y-axis, right? Does that make sense? So 3/7 and 4/7 would be symmetric about that y-axis. And your 6 pi/7 would go
In the same.
same quadrant, but really close. Yeah, like 1/7 away from that axis if you're dividing that upper half. So -3 pi/4. Can we do that the same way? Or maybe you already know if you studied the unit circle last year.
I mean, like 3 pi/4 is just like 2 pounds out.
Oh, that's true. Yeah. Oh, I skipped that one, didn't I? Sorry about that. 3 pi/4. Show me the direction, please. 3 pi/4. Nice. Do you change that to degrees? Or do you see that it is 3/4 of 180?
Are we drawing that or are we?
Oh, thank you. What does it say?
That's just.
Oh, it says, I'm sorry, it says change into radian. Okay. Yeah, so I'm sorry, I got distracted. I forgot what we're doing. So this does have to be multiplied by 180. And whatever that equals. What did you get for this? 77.1? Oh, 1428 okay. Degrees. Maybe I'll put a 6 right there. Degrees. So yeah. Okay, so this was just negative, and this one was 135 degrees. Negative 135 degrees. Sorry if I'm going over this too quickly.
Wait.
Can I help us with it? Yes,
Radians is an angle measure, right?
it is. Yes.
But. Is it also the circumference of a unit circle?
It has to do with circumference of the circle.
Oh,
Directly.
is it also a measure of length?
No, it's just related to that length, but it isn't the measure.
180 divided by 4.
I 2 pi/4.
And this actually gives us the definition of a radian. How many degrees was this? No, this is 1 radian. Pi radians would be 180 degrees, but 1 radian,
It's 8,
V8, is that what it is?
yeah. Like
In order to do this, we're gonna have. What's on the bottom? Pi. Change to degrees. Okay, so this is exactly 180 divided by pi degrees, and which is
A little.
a little over 60.
a little over 60.
Is it?
Oh, no, it's
We're
180.
dividing by more than 3.
Oh, whoa, yeah.
A little bit. I like that you're relating it to 60 because dividing by 3 would be 60. So dividing by more than 60. I think we get about 57 degrees. Is that right? About 57 degrees. And so what this is if we were to look at a circle and take the radius, wrap it around the circle, just 1 radius wrapped around the circle, we would have the exact measure of 1 radian. By definition, it's just that the angle that wraps 1 radius around the circle. It's about 57 degrees. Any questions? I'm going to give you until 10:13 to zone out or stretch or whatever you need to take care of. Thank you all for putting your phones in the caddy, by the way, and leaving them there for the entire period.
Do you mind if I step out?
Please go ahead, this one. Shoot.
I'm already on my,
Oh,
I'm already on.
Yeah, it's a hard habit to do.
Yeah, it's right.
Wait. Wait. So why can't we? That was one time.
Oh, right, that's what he said.
He would go.
Oh, so they.
That's the vibe.
Yeah.
What? Creates a different unit.
What? Oh, yeah. Oh, wait, oh my God.
There you
Okay, thank you for being back on time. Hey, did we talk about arc length sector area earlier today? I think we did. We're going to be talking about speeds in circles, but before we do, I want to show you a quick comic. Do you know Calvin and Hobbes by any chance?
Yes.
Thumbs up? Okay, yeah, one of my favorites in high school. Calvin and Hobbes, of course, is a comic strip. Here we go. Let's see what you. Does the idea make sense? Do any of you have a record player at home by any chance? You do? Wow. Okay, so it's a spinning disc. And it is interesting what he says that the point on the outside is going faster than the point on the inside, even though the record is traveling kind of at the same speed. So there's one more thing here. So punchline. And that's what some of the stuff we're going to be discussing today. Just we're going to touch on that a little bit, but cute, no? I love it. Okay. So arc length. We're going to make a little table down here. Arc length and sector area. Talk about it in radians and degrees. Because today we already talked about degrees. In this class, we're going to be using S for arc length. I'm not sure why, but that's pretty standard. So in degrees, to find the arc length of a circle, we take X degrees out of 360 and then multiply that by 2 pi r, yeah? Okay. For radians, is it going to be X degrees out of 360? No, it's going to be X. Well, we're going to use X. What letter do we normally use for angle measures?
Theta.
Theta. Theta out of what? 2 pi times 2 pi r. And notice how this simplifies super nicely, doesn't it? To give us that the arc length is just equal to theta times r. If you know the measure of the arc length in radians, just multiply that by the length of the radius to give us the arc length. We're going to do the same thing with sector area. I'll just call this A sub sec equals, in degrees, it's X out of 360 times pi r squared. We're just taking a piece of the area, like the first one was just taking a piece of circumference. In radians, does it work out nice and pretty? A little bit. Oh, theta over 2 pi times pi r squared. So the pi's cancel, leaving us with, normally what I write this as is 1/2 pi r squared. Not as elegant as the other one, but it's nice. Do you think these are two things you have to memorize? I think you could do it like you did the warm up, just a fraction, just make sure it's out of 360 or out of 2 pi, depending on what unit you're using. Yes, you have to write like 1/2. It's broader, you just put all that buckets. You can divide it out by 2. That's fine, as long as you're getting all of that in there. Okay. Find the length of the arc subtended by a central angle of 270 degrees in a circle with radius 5 inches. You may not know the word subtend, but maybe you could use contextual clues to figure it out. Looking for arc length. And now it's 270 degrees, so I'm going to be using the normal one. Figure that. Did I do that right? 15/2 pi inches. Did I get that right? Am I going too fast? So central angle, when it's something subtended, that just means like it's cut by the central angle. Did anyone go directly to 3/4 by any chance? Yeah. Or could you have, now that you think about it? You're welcome to take those kind of shortcuts. Yeah, try out all of these. Check with your neighbor when you are done or step. You're just working on these top 4. Work. You can if you want. Did you finish these next three? Check with your neighbor to see how they're doing. With words. Phrases like, how are you doing?
Six.
Yeah.
Okay, someone who hasn't given us an answer, can you help me through this one, please? It's just like the one, it's kind of, we already did this, 36 out of 360. Now it's area, so we're doing times 81 pi, is that what you did? So we have 1/10 of 81 pi. Is it okay to leave it like that? 81 pi over 10? Is that okay, or does it simplify? Oh, I knew the units, thank you. Square centimeters, can't forget that. Yeah, that could be a deduction on a test, so thank you. And sometimes if you have the wrong answer, just put the units in.
Do you want us to simplify that since we're just dividing by 10, or is that?
Good question. Is this fraction as simple as it could be? It is as simple, but it could also be expressed as specifically 8.1 pi, which I would think would be non-standard, but okay. As long as it's right. And we don't have a decimal in the fraction. We're good. Okay, this one. How should I do this one? Yes, Ria.
Well, I just did like pi over 5, and then on the denominator I did the 5 times 2 pi, because we're just dividing by 2 pi, so you can multiply it on the denominator.
And so
Like,
after this, you want to write 5 times 2 pi?
yeah, like on the bottom, like times 2 pi, you know.
Are you converting it or?
Or I just like, since you're dividing that whole thing by 2 pi, you can just multiply it on the denominator. Like, because you're multiplying by the reciprocal.
Okay, so you like this?
Mhm.
Okay, and why are you doing this?
So I can cancel out the pi and like the numerator and denominator, so you end up with like 1 over 10 times 9.
Are you going to degrees? Is that what's happening, or? I'm concerned about, I'm confused about the strategy.
Oh, well, I don't really know. I just like, I just use the formula we did on,
Okay, so pi over 5 times,
like pi r squared.
oh, times pi r squared. Okay,
And then, like, cause that pi over 5 needs to be divided by 2 pi, right?
does it? Well, let's see, so you're using the formula. It needs to be this, well, in the formula, this is it.
Oh, yeah.
We already
I was
canceled
thinking that.
Oh, you're using the first one, okay. No problem. Yeah, so we just need our theta just goes right there. You don't have to worry about the past.
Okay, never mind.
So you're on the right track. We have our, well, I guess we don't need this pi, do we? We have our pi over 5. So what else do I need?
Times-
All I need is we have this, I just need my 1. I see, so you're building it from the start.
Yeah.
Oh, okay. I see, and that's fine, that would work. But I do want to get some facility, which is going right here. So what do you get in the end?
9 pi over 10 feet squared.
Thank you very much. Pi over 10 square feet. Any questions? I see, so you're doing area equals pi over 5. Oh, kind of over 2 pi, you're doing
Yeah.
this, okay.
Sorry.
No, it's not a
Makes
problem.
sense in my head.
Yeah, it's not a problem at all. Okay, so that's, we were just having a translation issue. But yeah, what you did is perfectly fine. Thank you. And this one, find the length of the arc subtended by a central angle of 11 pi over 12. The radius is 2 meters. What do we do? Yeah, I'm here.
Just do it. That 8 meters, but
Wait, let me do this. Are we okay with this? Just multiplying this out? Okay, so 11 pi over 6. So I should change that to degrees? Or is this radians? Or what's the units? Or is it meters? So I do need to change that? Yeah, we don't need to change that. If I want to round that to a nearest decimal, I would probably need to get out a calculator. But that is an exact value. Thank you. Any questions? Okay. Ferris wheel with a diameter of 30 feet makes a complete revolution in 30 seconds. I don't like that it's the same. Let's make this a bigger Ferris wheel. How big should we make it? 60, yeah. Right, it's no good to have the same number. It's hard to follow it then. Sorry for those of you who went ahead. How fast is a carriage moving in inches per minute? Okay, and of course the carriage is located on the circumference of the Ferris wheel, so we're just looking at a point on the outside. So what we're talking about here is, since it's inches per minute, this is a linear speed. So for velocity, we're looking for S over T. Is a linear speed. And what do you think that S stands for? We just defined S as arc length. So you could use that relationship, and I hope that this makes sense. The velocity is just distance traveled over a certain amount of time. Intuitively, I hope that makes sense. I'm not going to use that definition. I'm going to use unit analysis or inversion. Let's see. Or maybe I will. Inches per minute. Oh, that is pretty fast, isn't it? Diameter of 60 feet makes a complete revolution in 30 seconds. Woo! Okay, so one revolution equals how much? How far does it go in one revolution?
Wait, 60 inches. So that's about 60 feet to inches or 60 times.
So it's
What's it?
2 times 60 pi, isn't it?
No, that's,
Feet. Is that right?
Yeah.
But we want in inches, interesting.
isn't diameter 60 or not?
Diameter, oh, so I'm back at 30. Foiled again. Good catch, thank you. Should we change it back to 30, guys? Is it too late? Okay, I'll go back. Thank you for reading. 2 times 15 pi. Okay, so that gives us 30 feet. We want to know inches though. So we have 1 foot is equal to 12 inches. So 360 pi inches. A minute. Okay, so it says it does 1 revolution in 30 seconds. Yeah, I think I'm gonna do it this way. 1 revolution in 30 seconds. I'm just gonna do some unit analysis here. I just found out that 1 revolution is 360 pi inches. And I need to go from seconds to minutes, so I know that 1 minute is equal to 60 seconds. So this was just a little bit of side work to get me through my conversion here. I start with 1 revolution per second. I'm trying to get to how many inches per minute. Is this easy to do? 30 goes into 60 twice. 2 times 360 pi is 720 pi inches per minute. Should I leave it like that? I don't think it's intuitive. You're not telling anyone you're driving 15 pi miles per hour, right? I hope not. Officer, I was only going 12 pi. Okay, I'll definitely be taken to jail with that attitude. So let's actually work that out. 720 pi is approximately, I don't have a calculator. It's over 1,000. Over 2,000. What is it?
2,000.
60.8. Thank you. Inches per minute. And notice I made an approximation. Notice the symbol that I've written. This one is an equal sign here. But this one, are you familiar with that one? That symbol that I just circled. The wave equal, approximate equal to. Anytime you make an approximation, I appreciate you changing your equal sign to approximation.
So we would not have calculated that. We would just have to like multiply it out. Or like.
Yes, I would actually, on a test, if you find yourself doing this, then you're probably doing extra work. So I wouldn't ask you to actually round it to the nearest tenth on a test.
You would just say that's fine.
Yeah, on a test, that would be fine, unless test allowed for a calculator. Right, please do not work your way through crazy multiplication. I know you know how to do it, and it's great that you can do it. But if you find yourself doing that, question your motives. And lastly, bicycle is cruising down a steep hill at 23 miles per hour. The wheel has a radius of 1.5 feet. How fast is the wheel spinning in RPMs or revolutions per revolutions or rotations per minute? We do this as units conversion.
Not a fun.
You're gonna start with 23 miles per hour. Does that make sense that I'm starting here? I'm going from miles per hour to revolutions per minute.
5,270, right?
What's that?
No, 5,280.
280. Yes, do you know that number? 5,280? Number of feet per mile.
Wait, do we need to know?
It's, yeah, you need to have
Okay,
it.
it's not as bad. It's not actually that. It could be worse. I
5,000.
thought it was 5,270.
Why?
Kilometers, yeah.
5,280.
Wait,
5,281.
No, it's not their fault. It's our fault not thinking about that.
I agree.
Because they say it's fault.
5280. What?
That's disgusting. At least do like, if you want to be different, 2,000.
Yeah, 5,000.
Yeah.
Yeah, kilometers.
And a mile is like a relative unit. You define it yourself.
Yeah.
This is why nobody uses miles.
How's it metered?
I don't even. They're like times
Something,
though.
but at least the something.
Like a kilometer.
No.
The long distances.
Yeah. Then they're gonna be trying to know that 1,700 like.
I'm trying to get to revolution.
Yeah.
But when we do like,
Exactly.
like what you wrote,
Yeah.
would you multiply it
Quirky, like the-
like 1 hour over 60 minutes? And then like
Yeah,
$5,000.
let's do this together. Let's have the dessert first. The easy part is to change hours to minutes. Should we do that first? Okay, did you do that already?
No.
Yeah, okay, well, 1 hour, and why am I putting hours on top?
Cancel.
To cancel the units. And this is what you've done in science, yes? Okay, so 1 hour is equal to 60 minutes. Stoichiometry, good times. Okay, so now we're at miles per minute, which is great. As we said, we're gonna have to go from miles to at least feet. 1 mile. Why am I putting miles on the bottom? Because there's miles on the top, so 50 to 80 feet. Okay, so we're in feet per minute now. Now I just have to figure out how many feet per revolution. How do we know how many feet per revolution? It is the, yeah,
95 feet.
how did you get that?
Wait. Maybe right.
How are you supposed to get the number of?
What did I
feet per
do?
revolution?
3 pi feet. Three
3 pi, are we good at 3 pi? And that came from?
circumference.
That's the circumference of the tire.
They put it-
It, every time it turns, doesn't it go, it's the circumference?
Yeah.
So. Feet go on the bottom, 3 pi feet, I think you said, is 1 revolution or rotation. So at this point, it would be appropriate to get out your calculators, except I'd probably cancel the tens at least. And just a tip for the calculator usage, when you're doing this, just do 23 times 528 divided by 6 divided by 3 is 5. You divide by 3 divided by 5. You have to make sure that you're dividing by that pi as well. Or you can use parentheses to keep top on top of pi. Again, 23 times 528 divided by 6 divided by 3 divided by pi to make sure you're dividing by pi. Or divided by 3 pi in parentheses. $2,118. Make sure you're using the pi button on your calculator, by the way.
Not using pi, using 414.
Oh, okay. With big numbers, it is gonna make a little bit of a difference.
Yeah.
Do you all see where the pi button is on a calculator? So on the right side, it's a second and one of those on the right. So 2,100 and 20. We're getting that?
What? Did you, what? No, it's like 214.
Second.
Is it? Did you multiply by pi? Or did you divide by?
Yeah.
You sure?
Okay.
I don't know, maybe. I haven't done this.
Oh. So I'm pretty sure it's 214.75.
Let's see.
It's like, you cancel out 60, you cancel out 60 and 5,280, you get 88.
Oh yeah, 6 goes into that.
Yeah.
And then 3 times 88 divided by pi is less than 1,000.
If we're just doing this, right? These kind of, yeah, it should be close to 500.
Yeah, it's 214.
Yeah, be careful how you did it.
How do you get the pi button?
Second, and there's a button on the
Yeah.
right side.
You're going.
There'd be a little pi.
Oh,
I think it's just that's now.
Yeah, fast. So I kind of, I guess I kind of makes sense, but like, so at the same time, like, I feel it's like really impossible. Like, I mean, like, it is like, if it's like, like, you're wrong. Yeah.
23, give me one.
Like, oh, what is it? It's down a C.
Oh. I miss.
So are you getting it? Are you getting it? So that's 2,000 or? But, oh, actually, it's gonna be less than 500 because it's still divided by pi. Right, this is about 1.
It's like.
It's gonna be like 200 something. 200 something you said?
14.75.
14.75?
Whoa.
Yeah, I got that.
What?
Okay, make sure you do this correctly. So if you have to use parentheses to keep things on top, that's fine, but I recommend just 23 times 5, 8, divided by 6, divided by 3, divided by pi.
What is it divided by 3 pi or divided by?
If you divide by 3 pi, it doesn't know to divide by that pi also. It's multiplying by pi.
Oh.
So if you put 3 pi in parentheses, it will divide by 3 pi. Our calculator is really tricky that way. Yes, Eileen.
Oh, it's dividing by three and then multiplying. it.
Pardon? In general, I do want,
No way.
let's actually get used to three if it doesn't say three. Do y'all hear that? Let's get used to three six figs. Or 3 decimal points would be more appropriate for this class. So 0.75 something else or? 75.
Yeah, so the next decimal point is zeros.
Wait,
Yeah, so what just happened is, those of you who did this, the calculator doesn't know that, I just put whatever here. If you're dividing by 3 pi, it doesn't know to divide by that pi. It's doing 10 divided by 3, and then multiplying that quantity times pi. So you have, if you want to divide by 3 pi, it's got to be in a parenthesis, or just also divide by whatever's on the bottom. So be careful about it. Oh, one last thing. We talked about linear speed. We have to talk about just a definition of this one, which is called angular speed. This is not a W, that's a Greek letter. Anybody know what that is? It is omega, lowercase omega. Who said that? Nice. It's omega, and this is equal to theta times. So looking back at the Calvin and Hobbes, every point on the circle is traveling at the same what? Angular speed. Does that make sense? It's traveling, it's going through the same angle all the time. But the outside is going at a faster linear speed than the points at the inside, if you're just following how fast the points are traveling. And therein lies the awakenedness. Would you please discuss with your neighbor the main points that we talked about today?
Difference between
Yeah.
Yeah, I still don't understand.
Yeah.
It's not, it's gonna be just about.
Yeah, what I did was.
Oh, yeah.
Okay, folks, have a great day. I'll see you next time.
All over 60, which is.